to go to further applications. In my case, what I do is I have a distributed model, distributed hydrological model with many parameters. In my case, I have selected 8 parameters, which are in the blue columns. Each parameter represents something. For example, the first and the second column represent the groundwater distribution or the groundwater output. The third one is the manning roughness, and the other parameters some other modules of my model, infiltration, for example, in my case. So what I do, one line is one sample, right? One sample. Each parameter is distributed, doesn't depend on the other parameter. It is independent, and each parameter can follow a different probability distribution. But as I said, usually at the beginning we have no idea. In case of the model parameters for complex models, we have no idea how this may behave. So what we can do is to start with a uniform distribution, and these are the Nash coefficient CE, which can be used as one indicator of how the sample, which is on one line, how the performance of the model is given the sample shown, like that. So that's the application. Once again, I'm using the CE, the Nash coefficient, as uncertainty measure. And yeah, as larger, if your random generation, if the series of samples is large, of course your estimations will be larger. So after I generate the samples, which are on the blue columns, then what I do is to generate the outputs. In this case, as I said, is a discharge hydrograph. This the white the numbers in the white cells show the dates, and these are the outputs based on the samples that I have shown you before, like that. So in my case, I haven't analyzed the outputs only based on simple statistics, but I have tried to use not complex but more sophisticated way to explain how my outputs behave. In my case, I have used some sensitivity indices whose explanation I may not give you today. So the result for my result in my case, only to show you how to apply this Monte Carlo, for example, one of the applications, is this kind of indices. Each line, each color, each trend shows the behavior of one index. As you can see, for example, in the case of the green index, it shows that it is very important at certain time step of the rainfall runoff process. In the case of the blue one, it has a behavior that it is opposite to the other one, right? I mean, it dominates the response during certain time, certain period, and it becomes not relevant for the model response during other periods, right? So that's one form to evaluate my results. Basically, is how I use the Monte Carlo for my simulations. So what I do is to generate data for sites where I have no idea how everything is behaving, and later I assume some distribution function for each of my input parameters. Those input parameters are calibration parameters whose behavior at the beginning I don't know. Later I change them manually, one by one, and after that I select which of the parameters might be more representative for the Monte Carlo analysis. And later, based on those, let's say at the beginning I have 20 parameters, for example, and later I reduce the number of parameters into only I don't remember how much, 7 or 8, I guess, and I make the analysis based on those. So that's basically what it is. So for the random generation, you can use the program, some program for sensitivity analysis, which I will upload in the blog, so you can go and just download it in case you want some basics of my work, for example. Okay, I hope this was useful. Thanks, and see you next time.